Thank you very much for allowing us to introduce Aviceda Therapeutics and our technology. The overview is Aviceda is not a complement modulating company. We are pioneering the use of sugars to mimic a particular sugars that will modulate the inflammatory system overall. Sugars, I am in the right conference, by the way. This is not the food conference, but sugars play a very important role in our immune system. In particular, sugars are found in all human cells, and they signal the immune system to either attack or not to attack. The molecule, or the sugar, sialic acid, is responsible for the stop light, the red light, or the green light. If there's sialic acid is present on the surface of these cells, then it's a stoplight to the immune cells so that they will brake and not run over the pedestrian, all right? Now, look at SARS-CoV-2, right? It is a non-sialated, very glycosylated virus, and it causes severe inflammation because it does not have sialic acid. And so it doesn't, it's like a green signal, a green light signal for inflammation to proceed. Now, the way this signal is interpreted is through sialic acid binding immune resolution receptors. There are many of them, but the first one that was discovered was complement factor H. If complement factor H is bound by sialic acid, it then will shut down the complement pathway. If the other family is called Siglex, and they are found in all activated immune cells. If they are bound to sialic acid, the appropriate sialic acid, they will stop the inflammatory cell in its tracks. So if you don't have sialic acid, well, the inflammatory system will just run you over. Now, Chris Scott, our scientific co-founder and the basis of Aviceda technology, developed a nanoparticle which was decorated with sialic acid, which was able to abrogate the inflammation in sepsis. Subsequently, other labs showed that in wet macular degeneration, or this model of laser-induced CNV, sialic acid could actually abrogate complement activation, macrophage activation, and inhibit neovascularization. In geographic atrophy, it's very well known that complement and activated microglial cells and macrophages play an important role in the growth of geographic atrophy. Actually, macrophages play a very, very important role in determining what disease a patient who has macular degeneration will develop. If you have more macrophages that are polarized to the M1 phase, you'll have a phagocytic macrophage, which causes geographic atrophy. If it polarizes to the M2D state, the VEGF-producing macrophage, guess what? You get neovascularization. What about if you polarize to the fibrotic state? You get fibrosis, disciform scarring. You've heard all that, right, clinically. All they're waiting for is a sialic acid signature that will shut them down. Now, in late AMD, there are all these Siglec receptors that are being upregulated in the macrophages and microglial cells of the retina. But they are not bound. They're not shutting down the inflammation because they are not recognizing the correct sialic acid pattern. Now, why is that? In late AMD patients, they are upregulating an enzyme called FUT5, FUT5. FUT5's role is to make the sialic acid on cells not recognizable by complement factor H or macrophages and Siglecs. So AVD104 is the molecule that we have designed to get that stop signal back into place. We have designed a nanoparticle coated with sialic acid, appropriate proprietary sialic acids, that will give the stop signal to these Siglecs and also to complement factor H. So we have demonstrated that our nanoparticle, AVD104, can bind to all the appropriate Siglecs on macrophages, both human and non-human, We also know that to activate CFH, you have to bind sialic acid to the 2 regions of CFH. And we designed our particle to do that. Furthermore, it has to bind to the correct Siglex on the correct polarized macrophage. And so we've demonstrated all this, and I'll show you the data. We can actually bind with AVD104 both the sialic acid binding regions of CFH in the wild type as well as the polymorphic type called the Y402H CFH. And it does hyperactivate CFH and shuts down complement activation. We can also convert the phagocytic macrophage into the resolution state. We've shown this in vitro. We've also shown it in vivo in a mouse model of severe retinal degeneration called the bright light damage model. We were also able to convert the angiogenic macrophage into the resolution state, and we were able to inhibit laser-induced CNV commensurate to the ILEA control. We have now developed a very strong pre-IND safety package. We have injected this in over 100 animals and shown absolutely no adverse events, no inflammation, no electrophysiological changes, and no ERG changes. We also know that it goes to where we want it, the outer retina, and it lasts for a long time, to a point where we probably can inject this molecule every 3 months and still have a very strong effect. In summary, we have developed a novel sialic acid mimetic nanoparticle that can profoundly halt GA growth with a safe way and without conversion to choroidal neovascularization. I need to thank my management team. Our management team, I calculated, we have over 120 years of retinal drug development. My scientific advisory board, they're world-renowned, and my scientists, they are the pioneers in glycobiology, glycochemistry, and glycoimmunology, and glyco-oncology. Thank you very much.